Hi everyone, in this video you're going to learn how to use the measures of central tendency. So this may sound like a really complex term, but a lot of people know this more commonly as range, median, mode, and mean. So all of these are ways to identify a reference point from a set of data. In fact, these are used in healthcare, insurance companies, and even the stock market. So let's just begin by defining it, right? So measures of central tendency, as I said before, are ways to identify a reference point from a set of data. Okay. So now let's get into the four types of central tendency, right? So, or more betterly phrased, the four ways of finding a central tendency. So the first way we're going to go over is the range. So the range is basically the difference between the highest and the lowest number in the set. So let's write that down. Okay, fine. So let's look at a brief example, right? How do we compute range? So first, let's create a generalized set of data, right? And let's call it set A, right? Okay. So now what we're going to do is we're going to draw our curly brackets, and let's make them maybe 2, 5, 8, 18, 25, 19, and 85, right? Okay. So first, in order to find the range, we need to find the lowest term in the sequence, right? Or in the data set. And looking at my numbers, I see that my lowest is the number 2, right? And now we need to identify our highest number, which in this seems to be 85, right? So as we defined, it was the difference, right? Or basically in my head, difference always translates to subtraction. So what we're going to do is to find the range, we're going to subtract 2. So from 85, the highest value, subtract 2, which is equal to 83. So we know that the range of the set is 83. So in more formal terms, range is actually used to find the spread values of a set. So now moving on, let's go over what the median is. So the median is the middle number when the numbers in a set are ordered from greatest to lowest. So median is the middle number in a set. So a really important part here is ordering your numbers when finding the median from lowest to greatest, right? Now I'll show you greatest. Okay, so now I'll show you why that's so important. So let's come back to our set A, right? So we have our set A to be 2, oops, I'm gonna make this black again, okay. 2, 5, 18, 25, 19, and 85, right? Okay. So now that we have this, let's try finding the median. We get cancel out 2, 85, then 5 and 19. And then we're left with 2 middle numbers. Now, if you have an odd number of set, you'd actually go canceling all the terms until you're going to go canceling 2 pairs from outside to inside. It's how I like to remember it. And you're ideally going to be left with 1 number. However, when you have 2 terms, what you're going to do is you're going to add the 2 terms and find the average, or just divide by 2, which we know is equal to 43 divided by 2, which is 43 and a half is our median. Now, looking at our data set, that seems very off, because if we were to convert this into a decimal value, we'd get our median to be somewhere around 21.5. Yeah, that seems about right. So our median actually seems like it should be a bit closer to 20, right? But it's not so big in this value. But let's see if it really does vary if we order it from lowest to greatest. Let's see if why this is so important. So ordering it, we know that 2 comes first, then 5, then 18, then 19, then 25, and then 85. Okay. So now let's go about canceling. 1, 2, and now we come down to 18 plus 19 divided by 2. So we know that 18 plus 19 is equal to 37. We get to divide that by 2. And now we get 18.5. That is a difference of almost 3, right? So in data, this is basically an incorrect answer because you're 3 off from the right median. That's a lot, right? So what you always need to do is you need to make sure, this is really important, guys, so please don't forget this, always order from lowest to greatest and then start canceling. Okay, so why do we use median? So we'll go over another measure of central tendency known as mean. They essentially find very similar values, with the median finding the middle value and the average finding with the mean finding the average, which is a more precise middle value. However, a mean can only go precise until a certain value. The reason being is that the mean is influenced by certain outliers, whereas the median is not. So when you have a data set with a lot of outliers, like see in set A, the data set seems to be pretty evenly distributed from 0 to 25, and then you get 85. This term, which is out of place, is known as an outlier. So when you have a data set with an outlier, it's highly recommended that you use median as your measure of central tendency, because it gives you a more accurate number. So talking about mean and average, let's get into what is mean, right? So in actually very simple terms, oops, I forgot to go shift text. Mean is the average of all the terms in a data set. Okay, so for this, what I'd actually like to do is I'd like to create a subset of A. So what I'm going to do is I'm going to change my color. I'm going to, okay, so come over here and we're going to make a subset of A. And we're going to keep everything the same. And we're just going to take out 85 though. because it's an outlier, I want to show you guys what happens to the mean when there's an outlier versus no outlier, right? So first, let's just learn how to calculate the mean. 18, 25, and 19, right? So these seem to be quite evenly distributed. So as in, they're centered around a certain number set. So like from 0 all the way to 29, it's centered from this data value. So it's pretty evenly distributed. And the amount that the difference between each term isn't as big as per se the difference between 2 and 85. So now let's just find the mean for sub of A. Okay, so how you find the mean is basically the same thing as finding an average. What you do is 2 plus 5 plus 18 plus 25 plus 19 divided by the total number of terms. So we know that 7 plus 18 is 25, and 25 plus 25 is equal to 50, and 50 plus 19 is equal to 69. And we divide this by 5 terms, which is 69 divided by 5, which can't really be simplified. So, but even if we try to make an improper fraction or like a complex fraction, it would be 13 over 45, right? But now let's find the mean of set A, which would basically just be 2 plus 5 plus 18 plus 25 plus 19 plus 85, right? So now make sure that you account for the extra term that you just added, right? That's 5 plus 1 because we added an extra term of 85. So then what we know is that 69 plus 85 is equal to 154. Yeah, okay, 154 divided by 6, right? So dividing this by 6, I'm pretty sure it's not divisible because it's not divisible by 3. But if we were to simplify it, I believe it would be somewhere around it would be 25 and 2/3. Okay, so first of all, let's just basically understand what mean is, right? Mean is just the average of a set, right? But let's actually understand what happened between these two sets. The reason why sometimes actually median is preferred over mean. So I'd just like to acknowledge before we get into the difference that mean seems to be more precise, right? You're adding up all the terms, dividing by the number of terms. It seems like a very precise way of calculation, right? But the problem with mean is that it gets influenced by outliers, right? So the big values that don't necessarily follow the same range of numbers, they influence the mean. Like just look at it here. Adding 85, the difference between 85 and just without 85, that seems to be massive. It's like almost 12 and a half. Difference is 12 and 2/5, sorry, not 12.5. Wasn't accurate, right? The difference, that's humongous, even more bigger than the difference in when we made a mistake from medians. It's the difference here is colossal. And this is simply because there is an outlier. And that's exactly why when there is an outlier in the data set, it's not recommended that you use the mean. It's more recommended that you use the median, as it gives you more accurate results in terms of outliers. Okay, so the final term that we're going to go over is mode. So mode is the most commonly occurring number. So I like to think about mode being popular, right? For two reasons. One, because it's actually one of the easiest data types, like one of the easiest measures of central tendency to find. And two, because mode measures the most commonly occurring number. So let's look at set A, right? In set A, I actually don't see any repeating numbers. So set A, oops, I forgot to change door. Okay, so set A has no mode. But what we can do is, let's say we added a term to set A, right? And let's say we added another 5 to this data set. Since 5 is the only number that occurs twice in the data set, see 5 and 5, and no other number repeats that many times, set A, the modified set A, would have a mode, oops, would be 5 because it's the most popular number. Okay, so this is the video on measures of central tendency. I've actually created a note sheet on this that should help you further your understanding, because I have a few practice problems with explanations, and I'll be posting the answer key to the document after this video. So yeah, thank you so much for watching this video, and the link to this note sheet will be linked in the description and in my channel bio. So yeah, thank you so much, guys. Have a great evening. Bye.